right, let's go through these three. And I'm happy to go as slow or as quickly as we need to, because like I said, I'm mainly using this right here to make sure that we're prepared for the quiz tomorrow. From section 1.1, I think the most confusing thing is just rewriting those absolute values without the absolute value symbol. But we did a bell work on that on Friday. Are you guys feeling better about that overall? That if what's inside the absolute value would evaluate to be a positive, you just drop the bars and rewrite what's inside. If what's inside the absolute value would evaluate to be a negative, distribute a -1 to everybody. And that's how you rewrite it without the absolute value. All right, so let's go through part G here. Where do I want to begin approaching this problem at? Under the radicals. We're going to multiply these pieces together under the radicals. They have the exact same index, and so I'm allowed to do that. If they did not have the same index, I couldn't do it. So I'm going to have the cubed root. Let me scoot that down just a little bit. There we go. Of 16 x to the 6th, y to the 5th, and then z. Is there any way to simplify the cubed root of 16? Yes, because 16 is what to what power? How could I rewrite that or think about it differently? 2 to the 4th power. So I'm going to do the cubed root of 2 to the 4th power. So what can I take out then? Aiden, did you have a thought?
You have 2 on the outside and 2 on the inside.
Yes, absolutely correct. We're going to have a 2 on the outside, because what we're doing here is we're splitting up the cubed root of 2 to the 4th to be the cubed root of 2 cubed times the cubed root of 2. You guys agree that that is the same thing as the cubed root of 2 to the 4th? Well, this part right here, when I have something to the 3rd power and then I take the cubed root of it, those pieces will cancel each other out. And so I'm just left with a 2 that can come out of my cubed root. All right, I'm going to go ahead and write down that cubed root so that we can put the 2 underneath it. All right, what about with the x's? Can I take any of those out of the cubed root? X squared. Do I have any that need to stay underneath my cubed root? No. No. Okay. And then my y's. 1y. 1y can come out. Do we have any that have to stay underneath? Yep. Y squared stays underneath, and then there's just a single z, so that stays underneath my cubed root as well. And that would be my fully simplified answer. Yes, sir. Mm-hmm. Yep, absolutely equivalent. Yes. Good questions. Good questions. There's often many ways to think through, or as long as you're executing order of operations correctly, there's kind of a couple different starting places on many of these types of problems. Some people might look at these 2 cubed roots, simplify each one, and then multiply them together. I find that more complicated, but it would not result in a wrong answer. You could approach it that way as well. All right, for the 5th root, where did my notes go? There they are. For the 5th root, where should I start on part H?
Inside the radical.
Inside the radical. So what can I do inside the radical to help clean this up at all?
Make the negative exponents in the numerator.
Yeah, so this right here, when I take it up to the numerator, because it was a negative, when they're on opposite sides of the fraction, you're going to be subtracting whatever's on the other side. So I'm going to subtract a negative. So that's going to be the same thing as adding 7 here. And then I can do the same thing with the z's, right? Do the same thing right here. I'm going to add 2 to that. So I'm still going to have that 9 down in the denominator, but I have 2x to the 15th, y to the 4th, z to the 5th, all over 9. Correct? All right. What can I do from here? Is there anything that can come out from underneath that radical?
X to the z.
Yes, x to the 15 and the z. So tell me what I bring out to the front. X cubed
And z.
and z just to the first power, right? And then we're going to have the fifth root of 2y to the fourth over 9. Is it appropriate for me to leave my answer like this? No. Do you guys see how I have this denominator here? Even though I didn't write it this way, this is equivalent, x cubed z, to saying the fifth root of 2y to the fourth over the fifth root of 9. And that means that I need to rationalize my denominator. So I want to do something that's going to make that root cancel out. I'm going to rearrange some things on my screen real quick so that I have some more room to work. All right. There we go. Now I got a little bit more room. So when it's a square root, I just have to multiply by whatever's on the bottom, right? But this is not a square root. This is a fifth root. And so just like up above when we were talking about this cubed root stuff, 2 cubed can cancel with a cubed root, and then I can take that 2 out. I want to be looking for the same kinds of things with this fifth root. Nine to the fourth power is very large, isn't it? I'd prefer not to work with it if I don't have to. Is there a way that I could write 9 as a base with a power?
3 squared.
I can rewrite that as 3 squared. And we've got the fifth root of 2y to the fourth over the fifth root of 3 squared. I need 3 to the fifth power to make that cancel, right?
Right.
So what could I multiply top and bottom by so that I can rationalize this denominator? I know it has to be a fifth root, or else I can't do anything with those 2 roots. Remember, I want my denominator to not have roots anymore. Yes, ma'am? 3 to the third power is absolutely correct. You could have also chosen 9 to the fourth, but that is a much, much, much larger number that's going to make it more difficult to work with. And then we're going to have to simplify our root at the end, so we'd have to break it down. All right, so let's see what we got now. I have x cubed, I have z, and now I've got the fifth root of 3 to the fifth, which is just what? Just 3. So I'm going to rewrite this as 3. It has to stay in my denominator because that value was on the bottom of a fraction when it was inside my root. So when it comes out, it's still the bottom of a fraction. Think about it this way. What's the square root of 1/4?
1/8. Or is it 1/2?
1/2. The square root of 1/4, I take the square root of the numerator, square root of the denominator. I still end up with a fraction. Does that make sense? Okay, so I've got that, and now I need to simplify this fifth root. I have 3 to the third that I need to multiply with what?
2.
Yeah, 2y to the fourth. So I can multiply 3 to the third to 2 and simplify that, right? 3 to the third is what? 27, and 27 times 2? 54. Y to the fourth. You can write it like this, Or you can have the root up in the numerator. It could be x cubed z, fifth root of 54 y to the fourth, all over 3. This is probably the way I would choose to enter it into Canvas, because then I have everything in my numerator slash my denominator. So either one of those would be considered correct. So far, so good? Okay. For I, I'm going to make some room off to the right here because I ran out of room. What's the first thing I would want to do here?
Simplify inside our radical.
Simplify inside our radical. All right, so looking at my numbers, can I simplify those at all?
Yeah.
48 divided by 3 is 16. So I'm going to have the square root. I have 16 up in my numerator. Then I'm going to come over here and look at the a's. This time my negative is up on top, so it wants to go where?
Down.
Wants to go down to the bottom. So I've got like 1 plus 5 here. So a to the 6th in my denominator. How will I simplify the b here? Subtract it. So it's going to be b to the 5th, top or bottom? Top. B to the 5th. And then with c, add those. So plus 2. C to the, sorry, I wrote 7 and I meant to say 2. I was thinking 17. My brain was adding them already. So c to the 17th. All right. We do need to worry about this denominator. Anytime we have a denominator under a radical, we got to think about rationalizing it. Is it going to cause me a problem here?
No.
Why not?
It's a square root.
Because it is a square root. So 16b to the 5th, c to the 17 over the square root of a to the 6th. How will this simplify for me? A to the 3rd. And it's going to continue to stay in my denominator. So a to the 3rd. Square root of 16? 4. Can I simplify b to the 5th at all?
B squared.
B squared can come out. And I still have a b left here. Let's see if I can, I don't know if it'll let me, it won't let me delete that right now. And then c. C to the 8th. And I still have 1 left. So my final answer would be 4b squared c to the 8th square root of bc all over a cubed. How are we feeling about these so far? Give me a real quick like thumbs up, in the middle, or down. Cool. Honestly, if we are like sitting right here, I'm okay with that. When I hand you some of the ones that are, quote, easier, you feel comfortable with those. The more complicated we get, the more you're like, I keep making little mistakes here and there. All right. Oh, I grabbed the wrong thing here. I'm going to put 2 more up. I have 3 more of these total, and then we'll look at 1, 3. So let's look at these guys. Here's how I would approach J. First thing I'm going to deal with is this y to the negative 6th in my denominator. There's no reason for it to be down there, so I'm going to move that up to my numerator. So I'm going to have negative 64 x to the 5th, y to the 6th. This whole thing is being taken to the 2/3 power. So far, so good? All right. Would you guys agree that 2/3 is the same thing as 2 times 1/3? Okay. So that means I can look at this and I can like take the cubed root of everything and then I can square things and kind of see where that leaves me. You could do it the other way around, or you could deal with that 2/3 all at once. I like to look at the cubed root first because roots tend to make things smaller, whereas exponents that are whole numbers are going to make things larger to work with. And so I kind of like to make things smaller and easier to work with before I make them bigger. All right, so I'm going to be looking at this as negative 64 x to the 5th, y to the 6th to the 1/3, or the cubed root, and then I'll worry about that squared part. Can we do the cubed root of negative 64?
Yes.
Yes, what is that?
Negative 4.
Negative 4. So let's take that negative 4 out. X to the 5th. I can take one of them out. And then we still have how many left? 2. And then I'm going to have a y squared. So cubed root of x squared. Do you guys agree that this is the same as what I have inside the purple brackets? Okay. So I still have these purple brackets here, and this is all going to get squared. So I have to square each piece here. Negative 4 squared would give me 16. And then I'm going to have x squared and y to the 4th, correct? And then I'm going to have the cubed root of x squared squared, which is the cubed root of x to the 4th, right? This right here, cubed root of x to the 4th. Will that simplify at all? Yes. What can I do with that? I can take one more x out. So what will my final answer look like then?
16 x to the 3rd, y to the 4th, cubed root of x.
Yes. (16x cubed, y to the 4th, cubed root of x. That would be my final answer there. A 1/2 power is the same thing as what root? Square root. So I'm square rooting all the stuff inside this first set of parentheses. Square root of 25? 5. A to the 5th, what can I do there? Yes, I can do a squared, and then I would have square root of a, and then b to what? B to the negative 2, square root of a. We are going to multiply that. Cubed root first, and then we'll square it, right? So what is the cubed root of a to the negative 3? A to the negative 1. And then this would be the cubed root of b. This whole thing still needs to get squared, correct? Okay. So I'm going to have 5a squared square root of a over b squared. I'm going to go ahead and move that negative exponent down into my denominator, times I'm going to have the cubed root of b squared over a squared. And now I need to multiply these two together. For the most part, I'm not worried about multiplying these two together, but I do see two things that I'm like, I really don't want to multiply those. What are the ones that look like they're difficult? Yeah, I've got the square root of a, but over here I have the cubed root of b squared. All right, so I'm going to pull this off to the side and think about it for just a second. I have a to the 1/2 power, right? Times b to the 2/3, because remember I have b squared underneath there. If I had the same denominator here, I could write it as a single root, correct? But I don't have the same denominator. Can you think of a way that I could have the same denominator? How could I rewrite 1/2 and 2/3 so they have the same denominator but the same meaning? Yes, sir.
1/2 is 3/6, and 2/3 is 4/6.
If I write it like that, now I see that I can have a 6th root, and I can write this as a single root at the end. Does that make sense? Okay. So let's write this down. I'm going to have 5a squared, and then this is going to be the 6th root of a cubed b to the 4th all over a squared b squared. Can I simplify anything? The a squareds. Those can reduce. And so then I would rewrite my final answer without those a squareds. So 5/6 root of a cubed b to the 4th all over b squared. Is anybody else tired of exponents? I promise this course is not just all exponents, but when we're working on some new skill, I don't want it to be the exponents that trip us up. Did you have a question for me, dear? Yes, ma'am.
So, when you, like, say you have an exponent, and, like, you're, like, square rooting it, no, I'm gonna say cube rooting it, and it's, like, 5, like, so the x to the power of 5, and there's a cube root outside.
Okay. So like this?
So yeah,
Okay.
so that's supposed to simplify to x to the power of 2.
So what's going on there, if I rewrite that as just a rational exponent, that 3, because it's the index on my root, is going to be my denominator. So this would be x to the 5/3. So I'm thinking about this right here, 5/3. If I was going to write this as a mixed number, that is the same as 1 2/3, correct? So that tells me I can take 1x out, or x to the 1st power out, and I'm going to have an x squared left under my cubed root. Do you want to look at another one that's similar to that? Okay. Let's try that same idea, see if you guys can help me with this. I always think about them in terms of mixed numbers because that tells me what my power is going to be on the outside. That comes from the whole number. And any power that need to be on the inside, because that would be my numerator. So if I had x to the, let's do x to the 14th, and we'll do the 5th root. So if I write this as a rational exponent, I have x to the 14/5. So now I'm thinking about this. 14/5 would be what as a mixed number? 2 4/5. So that means that this right here is going to be x squared. That's coming from the whole number. And then the fifth root of x to the fourth. This comes from the fractional part still. Does that help?
Yeah.
Okay, good. Let's do one last one like this, and I'm going to introduce section 1.3. I know we're not going to get super far on it today. I was expecting that. It's all right. Last one like this, though. I want you guys to do this one, and then we're going to go through it, and then we'll talk about 1.3. I feel like I can finally feel that AC. I'm going to close the windows and see if we can't get it cooler in here than it is outside, but I feel like we finally have some air moving a little bit. That's not 80-degree air. Where do you guys want to start on this one? Yeah, let's take care of that z to the -4 right here. So I'm going to have 16 x to the 8th, y to the 20th, z to the 4th. I'm looking at those numbers, 8, 24, 16. What do I like about those? Yeah. I can do a fourth root of all of those pretty easily, even the 16. So I'm going to do the fourth root of all of this, and then I will cube the whole thing. What is the fourth root of 16? 2. So I'm going to have 2x to the what? X squared, y to the 5th, and z. And now I take that whole thing and I cube it. 2 cubed? 8. X to the 6th, y to the 15, z to the 3rd. Nice work. That one looked a hot mess at first, right? But it cleaned up fairly nicely. This right here is probably more of an indication of how we're going to see complex rational exponent situations simplify as we move forward in other problems. So if this one felt reasonably comfortable, I'd say you're on the right track there, okay? All right, we're going to just start to touch on this. You guys okay if I go to the next screen? Okay. 1.3, we're going to be looking at algebraic expressions. You guys told me last week, expression means what? What does it not have? Equal signs. We can simplify, we can evaluate, but we can't solve. Next slide I'm going to put up has several different pieces of important information. I want you guys to all pull your phones out. So we're going to snap a picture of this and go on to an actual problem, okay? But that way you can have it out next to you and I can reference it. All right, so I want you guys to snap a picture of this. I do not want to take the time to write all of it down into your notes right now. And I'll go through it just a little bit. If you see this, it kind of looks like an E, but if you wrote an E by writing a C first and then sticking a line in the middle, this is saying that A is an element of S. If you put a slash through it, it means it is not an element. S is a subset of T. To be an element of something, all of you guys are an element of my dual credit pre-calculus class. You are a member of this group. If I were to go next door to Mrs. Bolliton's room and pull a couple students in here, they would not be elements of this class because they're not enrolled in this course. To be a subset, if I were to take just this first table over here, this is a subset of our larger group. You are a smaller group that's contained within this larger group. A constant is going to be a letter or a symbol that represents a specific element of a set. Usually when we're talking about constants, we're talking about numbers, things that their value does not change. 5 is always 1, 2, 3, 4, 5. Variables, on the other hand, have values that can change. That's why we use a letter there, and we can substitute different numbers in and see what happens. What's a polynomial? An expression with multiple numbers. Something like 7 can be a polynomial. X plus 7 can be a polynomial. 3x squared plus x plus 7 can be a polynomial. We always write polynomials in decreasing order based on their degree, so the highest power. If we've got more than one variable going on, we put it in decreasing order based on alphabetical order. So if we have A and B, the A with the highest power goes first. Even if it has a B with it, that's okay. And you'll go all the way down through the A's, and then if there's any terms that don't have an A, even if they have a B, those go at the end, and we'll write those in decreasing order if necessary. Constants always go at the end. What's a leading coefficient? Yep. Yep, it's going to be the constant in front of our term that has the highest degree. Make sense? All right. Let's look at these real quick. Let's simplify these. What am I being asked to do on part A? What's in between my parentheses? We're supposed to add these. So I'm just going to be combining like terms. I've got 4x cubed minus x cubed, 3x cubed. I have 8x squared plus negative 5x squared, 3x squared. I come over here and I have a 3, but over here I have a 7x. Can I combine those?
No.
So what combines with my 7x?
0.
Yeah.
7x.
So I'm just going to bring that 7x down. He doesn't have a like term to combine with. And then I can combine the 3 with the negative 11, and I get what? Negative 8. What are we doing between the parentheses on B? Subtracting. So what do you have to remember to do? Distribute that negative to every single piece. So a lot of times I will rewrite what it is, and then I'll combine my like terms. I'll add them together. So I'm going to have a negative x cubed minus 5x squared plus 6x squared plus 1. Now we're going to combine anything that is alike. I've got negative 7x cubed and negative x cubed. So that would be negative 8x cubed. Do we have a squared term? Yeah, they're inside the same set of parentheses, but I still do have squared terms to combine here. I'm going to have just x squared, positive or negative? Positive x squared. Do I have any terms that have x to the first power? Negative 5x. So minus 5x. And then last but not least, plus 2, because I have a positive 1 here and a positive 1 here. Tomorrow after your quiz, we'll finish up these two, and then we'll continue rolling with 1.3. All right? Cool beans.